ইন্ট্রোডাকশন অফ টেক্সটাইল ইঞ্জিনিয়ারিং। এটার ভিতর দুইটা অংশ দেখতেছি, টেক্সটাইল এবং ইঞ্জিনিয়ারিং। তো এই সম্পর্কে আমরা জানবো টেক্সটাইল ইঞ্জিনিয়ারিং কি কি বিষয় কভার করে। প্রথমেই কিভাবে উৎপত্তি হইল টেক্সটাইলের। An evolution of textile. Although man's first article of clothing and furnishing were probably leaf animal skin were sometimes stitched together using bone needles and animals sinews. He soon attempted to manipulate fiber material into textile fiber, encouraged by gain from interlacing bands, leaves and grass in the production of primitive shelters. তো কিভাবে উৎপন্ন হলো? সর্বপ্রথম মানুষ পাতার দিয়ে জামা কাপড় পরতো, তারপরে এনিমেল স্কিন পশু পাখির চামড়া দিয়ে জামা কাপড় তৈরি করা শিখলো। তারপর মানুষ যখন বিভিন্ন ধরনের বাঁশ গাছের ডালপালা দিয়ে একটার সাথে একটা জুড়ে যখন বেড়া তৈরি করা শিখলো, তারপরে এই পরিকল্পনা থেকেই তারা জামা কাপড় বানানো শুরু করলো। তারপর আসতেছে টেক্সটাইল কি জিনিস। টেক্সটাইল any filament, fiber or yarn that can be made into fabric or cloth and the resulting material itself. The term is derived from the Latin textiles and the French texta, meaning to weave, and it originally referred only to woven fabric. It has, however, come to include fabrics produced by other method, thus threads, cords, ropes, braids, lace, embroidery, nets, and fabric made by weaving, knitting, bonding, felting, or tufting are textile. Some definition of the term textile would be also include those products obtained by pre-making principle that have many of the properties associated with conventional fabric. অর্থাৎ টেক্সটাইল হচ্ছে একটা ফিলামেন্ট, ফাইবার আর ইয়ার্ন। তো ফিলামেন্ট কি, ফাইবার কি, ইয়ার্ন কি, এর সম্বন্ধে আমরা সামনে জানবো। তো টেক্সটাইল টার্মটা আসছে ল্যাটিন ওয়ার্ড টেক্সটাইলাইজ থেকে আর ফ্রেঞ্চ টেক্সটা থেকে, যেটার অর্থ হচ্ছে ওয়েব। আর এটা ইন্ডিকেট করে ওভেন ফেব্রিকের দিকে। তারপরে আসতেছে ডেফিনিশন অফ টেক্সটাইল। টেক্সটাইল ইজ এ fabric woven or knit made by from yarn. Though it is referred to woven fabric, it is also applied to fiber, yarn, fabric and many other products made from those. It is also associated with the production of clothing. টেক্সটাইল হচ্ছে একটা ফেব্রিক, ওপেন অর নিট, যেটা তৈরি হয় ইয়ার্নের মাধ্যমে। তো ইট ইজ রেফার টু ওভেন ফেব্রিক, যেটা ওভেন ফেব্রিকের দিকে নির্দেশনা করে। ইট ইজ অলসো অ্যাপ্লাইড টু ফাইবার, ইয়ার্ন, ফেব্রিক অ্যান্ড এনি আদার প্রোডাক্ট মেড ফ্রম দোজ। ব্যবহার করা হয় ফাইবার, ইয়ার্ন আর ফেব্রিকের দিকেও, যেটা অন্যান্য দ্রব্য তৈরি করা হয়। Textile is a very widely used term which includes all kind of fiber, all kind of process, spinning, weaving, knitting, dyeing, printing, finishing, all kind of machineries, spinning, weaving, knitting, dyeing to convert textile fiber into finished or end use, garments, household textile, medical textile, shoes textile, finishing textile ইত্যাদি। টেক্সটাইল এই ওয়ার্ডটা বৃহৎভাবে অনেকগুলা টার্মকে নির্দেশ করে। টেক্সটাইলের ভিতরে আছে সকল ধরনের ফাইবার, আঁশ, কটন, জুট, ভিসকোস আর সব ধরনের প্রসেসও, স্পিনিং প্রসেস, উইভিং প্রসেস, নিটিং প্রসেস, ডাইং প্রসেস, প্রিন্টিং প্রসেস এবং ফিনিশিং প্রসেস। আর টেক্সটাইল আরো ইন্ডিকেট করে সব ধরনের মেশিনারিজের দিকেও, স্পিনিং, ওয়েভিং, নিটিং, ডাইং, ওয়াশিং, বয়লার, সুইং মেশিন ইত্যাদি। তো হোয়াট ইজ টেক্সটাইল ইঞ্জিনিয়ারিং? টেক্সটাইল ইঞ্জিনিয়ারিং কি? Textile engineering is an area of engineering that use scientific and engineering principles to produce or improve textile products such as apparel, upholstery or materials from medical device. তো টেক্সটাইল ইঞ্জিনিয়ারিং হচ্ছে বৈজ্ঞানিক উপায়ে তৈরি একটা মাধ্যম যেখানে টেক্সটাইলের জিনিসপত্র, অ্যাপারেল বা গৃহস্থালী পণ্য, মেডিকেলের ডিভাইস এগুলো নির্দেশ করে। What is object of textile engineering? Object of textile engineering to produce engineer and technologist conversant with cotton and multi-fiber technology and capable of servicing textile industry in product testing and quality control, ready-made R&D, research and development and other related fields. Swing thread. Swing thread are tightly twist ply yarn made with strands having equally balanced twist, producing a circular cross-section thread for use in commercial or home sewing machines and for hand sewing should allow easily movement when tension is applied, and case in needle threading should be smooth to resistant friction during sewing, should have sufficient elasticity to avoid the breaking of stitches or parking of seams, and should have sufficient strength to hold seams during laundering or dry cleaning and in use. By introducing metallic threads into weaving composite of other fibers. Thread of special use many required appropriate treatment. Garments made of water repellent fabric, for example, may be sewn with thread that has also been made water repellent. Thread is usually subjected to special treatment after spinning and it is then wound on spool. Thread size is frequently identified on the spool end, and system for indicates degree of fineness vary according to the textile measurement system used locally. Silk thread has great elasticity and strength combined with fine diameter. It can be permanently straight in sewing. It is suitable for silk and wool. Buttonhole twist is a strong lustrous silk about 3 times the diameter of normal sewing silk, and it is used for hand work buttonholes, for sewing on buttons and for various decorative effects. Cotton threads is compatible with fabric made from yarn of plant origin such as cotton and linen, and for rayon made from a plant substance because it has similar shrinkage characteristics. It is not suitable for most synthetics, which do woven fabric, but not for knits, which requires more stretch. Nylon thread is strong with great stress and recovery, does not shrink, and it's suitable for shears and very strictly knits. Polyester threads has similar characteristics and is appropriate for various synthetic and pre-shrunk fabrics for the knits made of synthetic yarn. Why do I need to measure yarn count? Before we get into all those figures and formulas, you may be wondering why yarn count is so important. Here are just few reasons why knowing the yarn count is essential to manufacture and sourcing and fabric and garments quality. Yarn count can be tell you a lot about the yarn's durability, strength and comfort. It will help you to determine whether a yarn and the fabric are suitable for purpose of you have in mind. Price. Yarn count affects the price of fabric. The finer the yarn, the more expensive the product. Yarn count also affects the weight of fabric, which can gain impact of product price. Purchasing. When you understand yarn count, you will find it easier to search for a fabric you need. You will be better able to continue with the supplier to check the fabric you order is to be correct specification. How to check yarn count for filament yarn? The yarn count of filament yarn is commonly measured in denier. The denier can be calculated using weight per unit length system, where the fabric weight is figure remains a constant. For example, 9,000 meter of yarn equal to 1 gram equal to 1 denier. 9,000 meter of yarn equal to 100 grams equal to 100 denier. The bigger the denier number, the heavier, thicker and cheaper the yarn will be. The smaller the denier number, the lighter, thinner and more expensive the yarn will be. In Taiwan, the most common denier specification for polyester used in garments are 50D, 75D, 100D and 150D. You may also see a yarn count that looks something like this: 75D, 72F. So what does this mean? Filament yarn composed of multiple filament fiber. The figure above tells us that the yarn is 75 denier and composed of 72 filament fiber strands. If the filament number is greater than the denier, for example polyester 50D by 72D to 72F, we call this yarn a microfiber. Beside denier, there is another way to measure filament called tex, but it is less common. 1000 meter of yarn equal 1 gram equal 1 tex. How to check yarn count for staple yarn? We can measure the yarn count for staple yarn using a weight per unit length system. In spinning industry like to us a process based upon English cotton count. This yarn count is determined by the number of yarn hanks equivalent to 1 pound of yarn. This method is measured in NA, rather than tenure of text. It is commonly written as, for example, cotton 100, cotton 20s. 840 yards equal to 1 pound equal to 1 NE or 1 S. 840 yards into 2, 1680 yards equal to 1 pound equal to 1 NE or 2S. Using this system, the larger the number, the finer the yarn, and vice versa. How do we check yarn count for blended yarn? We get yarns blended with 2 or more different materials for all sorts of different regions to enhance a fabric qualities, to reduce the cost, and even to create different dyeing effects. When it comes to measuring the yarn count of blended yarn, it is easily quite simple. The measurement we use depends upon from the form of fiber. If the yarn is staple yarn, we can use any S or text measure. If the yarn is filament yarn, we use denier or filament. Yarn conversion calculator. Yarn conversion calculator in text, denier, Dexitex, linen, hemp, jute, woolen, and woolen US grain. The higher the number, the thicker the yarn. For all other countries, the higher the number, the finer the yarn. If we put yarn size here, we want text, then calculate measurement value. Text 409 grams per kilometer, denier 3681 grams per 9000 meters. Dexitex, linen, woolen US grain, asbestos English, cotton bump, cotton English, glass, linear, what is yarn count in textile? In all the different branches of textile industry, it has been found necessary to adopt some method of numbering the different size of yarn. This invariable custom is practiced partly in order to yarn of different thickness may be distinguished from each other, and partly from import, an essential function of facilitating calculation when the weight has been taken into account in the process of manufacturing. Yarn count is an important index of distinguish different yarns. Yarn count is the degree of yarn thickness which can be expressed by means of S, D, N, tex, D-tex, and so on. S and D are more commonly used, while a specific fiber use a specification. For example, the text is commonly used in scientific literature. Yarn count unit. S is the British count. If it refers to the how many 840 yards of the yarn's length, which is or the number of yarn counts with a pound yarn under the public moisture regain. The thicker the yarn, the smaller the S value of the yarn. For example, the 40S yarn is thinner than the 20S yarn. D is the abbreviation of the denier, the expression of the fineness of the chemical fiber. It means that the yarn, the weight of grams of 9,000-meter long wire at a public moisture regain, the larger the D value, the thicker the yarn is. For example, 75D is thicker than 50D. Text, also known as number, referred as a special hold known as a public branch. It refers to the number of grains of weight of 1000-meter long yarn at a public moisture regain. Text, short of T, it refers to the grain weight of number of 1000-meter long yarn at a public moisture regain. N is the metric branch. It refers to that how many 1 meters of the yarn length, which is what the number of yarn counts with on grams under the public moisture regain. For example, 1 grams weight yarn length is 200 meter long. The fineness of the yarn count is 200. T-text is refers to the grade numbers of the bundles that has 1000 meter long. The following are the interconvention formula for several units. D equal to 5315 by S. D equal 9000 by N. Text equal to D by 9. 1 text equal 1 by 10 D text. Text equal to 1000 by N. D text equal to 10 D by 9. D text 1000 by N. In the textile industry, the yarn count is used to express how fine or coarse or thin or thick the yarn is. We use the English count numbering system, which is a part of large group known as indirect count system. Those systems, along with the direct count system, consist of multiple numbering systems, simple language that classify yarn characteristics of manufacture all over the world. Yarn count system with a bundle of yarn. Knitting and hobbyists are familiar with bundles of yarn, like a ball of yarn that gets ply with the skein of yarn can buy a craft store. This type of yarn is sold recognizable and manageable shapes for retail, but other type of bundle known as hang, it is used how long is a hang? A hang of yarn is English count system equals 840 on yard length or 8.5 football fields 100 yards long. The English count is the number of hands required to weight pound of yarns. Remember that fact for later. Of course, no one run up and down a football fields to measure a hang. System used to determine yarn count. As mentioned before, there are multiple numbering systems used to arrive at the yarn count, which fall into two categories: direct count system and indirect counting system. The text, denier and jute system are direct count systems that use a fixed length and variable weight to arrive at their use. Those systems assign their number to coarse yarn. English count method. Yarn count math for 1 by 1 or 1s. One hank of 840 yards of yarn weighs 1 pound, or 1 into 845 yards equal to 840 yards equal to 1 pound. 1 by 1 NE or 1s. Yarn count math for 20 by 1 NE. Twenty hanks of 840 yards of yarn weight 1 pound. 20 into 840 yards equal to 16800 yards yarn equal to 1 pound. How does single versus double affect yarn count? What does yarn count mean in the real world? Components are some product and their yarn counts for a better understanding of yarn count. The significance of yarn count. Although there are many different methods or systems of indicating the number, size, grist or count of yarn, considering the relation between its length and its weight, all those systems, yarn count system in textile, are modification of two direct distinct groups. One, that is which a given length is constant for any particular system and the weight of the length is variable. 2. That is which the length is variable and the weight constant for any particular system. The choice, if the length in group or the weight in the group 2, is quite arbitrary, and in that those are many variations of both groups. For the sake of distinguish between the two distinct group, you can adopt the following definition. Group 1 equal to fixed length system, group 2 equal to fixed weight system. In all the fixed length system, the number or count of the yarn is directly proportional to the sectional area of the yarn, whereas in the fixed weight system, the number or count of the yarn is inversely proportional to the sectional area of the yarn. In other words, you can have fixed length system, the thicker the yarn, the higher the count. Fixed weight system, the thicker the yarn, the lower the count. Interpretation of yarn count. The yarn count is extent of yarn thickness. The higher the yarn count, the finer the yarn and the thinner the cloth. The softer and more comfortable it is, but the high count of cloth requires high quality of raw materials and have requirements for yarn mills and textile weaving mills, so that the cost of cloth is high. In the industry, the cloth is largely non-counted and is mainly expressed by the density of yarns. In density of yarn refers to the Root's number of warp and weft yarn arranged in square inch, also known as warp and weft densities. Generally expressed by warp yarns number, weft yarns number. For example, 110 into 90, it means that there are 110 warps and 90 warps weft yarns per square inch. Misunderstanding of yarn count. Myth 1. The more the coats, the better. The higher the coat counts, the thicker the cloth. The higher the density, not necessary. It is better of the higher count under the same density, but the lower the count, the thicker the yarn, the thicker the cloth. Myth 2. The cloth is poor with 30s and 40s. This is not the case. Over 95% of the big brands are 30s and 40s. It can be said that majority of the suppliers we see now 30s or 40s. Myth 3. Excessive pursuit of high numbers and high density. At present, most of the cloth product in the market are 40s. If you listen to those business said they are 40s cotton, even 80s, but be careful because the more the count, the more delicate the cloth color, and the more the dense the cloth, the price will be very expensive. Is the cloth with 80s worsted, it is difficult to shop because too dense. Calculating the yarn. The yarn count can tell you a lot about yarn durability, strength and comfort. It's an important number and that means it's on that you don't want estimate. You can probably guess where this is going. We are going to have talk about math and in the textile course. In most basic sense, the yarn count represents either the mass per length unit or length per unit mass of the spun yarn. Let's look direct system. Let's start with the first method of calculating the yarn count, the direct system, which calculates the weight of the yarn by treating the length of the yarn as the constant in the formula. Basically, it helps you answer the question, how much does constant length of yarn weigh? That's the yarn count represent in the system. A higher the count represent a heavier and therefore coarse yarn. Indirect system. What are the different types of yarn twist? A twist yarn spun of staple yarn twisted in clockwise direction is called a twist. Jet twist yarn spun or staple yarn twisted into anti-clockwise direction is called Physical properties and performance. Physical properties and performance characteristics of yarn. Yarn types. General yarn properties. Staple yarn, carded cotton, combat cotton, woolen, worsted linen. General yarn properties. Excellent handle, good covering power, good comfort rating, reasonable strength, reasonable uniformity. Continuous filament yarn, natural, non-synthetic, synthetic. Excellent uniformity, excellent strength, can be very fine, fair handle, poor covering power. High bulk yarn, staple, continuous filament, good covering power with lightweight, good loftiness or fullness. Stressed yarn, continuous filament, high strength ability, good handle and covering power. Special end use, tire cord, rubber, elastic cord, yarn, cable corded. Types of yarn. Ring spun yarn, those are the produced on the ring and travel system for a wide variety of yarn. Rotor spun yarn, flat continuous filament yarn, textured continuous filament yarn, twistless yarn, coarse yarn, self twist yarn, friction spun yarn, folded or plied yarn, cabled yarn, a yarn in which two or more folded yarn are twisted together in one or more operations. Folded and cable yarn can be produced from staple yarn. End use of plied and cable yarn, 2-ply, 3-ply cable yarn, 2-ply poplin swing thread industrial yarn, cabled yarn, Wales industrial yarn, electrical insulation, gabardines, canvas, shoelace, clips, filter cloth cord. Fancy yarn. A fancy yarn can be defined as one of the different from the normal construction of the single or double yarn by deliberately introduce irregular in its construction. What is staple fiber? Staple fiber yarn are made from short fiber bound together by twisting. Those fiber can be natural cotton wool, jute, flax, man-made viscose. Staple fiber. Filament fiber, staple fiber. Filament fiber, staple fiber. Flowchart of typical flow. Short staple fiber, long staple. Long staple fiber have a length of more than 60 mm. Wool fiber are long staple with a long length of length about 60 to 150 mm. As a result of their short length and non-uniform nature, stable fiber required gather processing before a satisfactory yarn can be produced. This obviously adds to production cost. Typical flowchart of short staple spinning: blow-room, carding, drawing, roving, ring frame. Blow-room, bell opener, then goes to pre-cleaner, then goes to mixer, then fine cleaners. To the cards, bell opener, in blow-room section. Picture blow-room section: bell opener, pre-cleaner, mixer, fine cleaner. Bell opener, carding, hardened process of yarn making. Then drawing, roving frame, can, guide roller, back zone, middle zone, the twisted roving system. Then ring frame, blow room, cleaning, dust removal, blending, when feed of the material. Carding, roving frame, what is carded yarn, combat yarn. What is carded and combat yarn? Difference between carded and combat yarn. In short staple spinning, three types of spinning system are available in wide range. In ring spinning, carded and combat yarn are produced according to the requirement of the yarn quality. Difference between carded and combat yarn. In short staple spinning, those types of spinning system are available in wide range. In ring spinning, carded and combat yarn are produced according to the requirement of the yarn quality, price as well as time consumption. Carded yarn are highly used for medium quality and average count, used for all kinds of fabrics. Flowchart of carded yarn manufacturing process: fiber, then blow room, lap, carding, cut sliver, first row frame, grown sliver, second row frame, grown sliver, simplex, roving, ring frame, yarn, then winding, reeling, bundling, baling. Comb yarn is a very much high quality yarn in comparison with card yarn. Cause of here more short fiber and naps as well as impurities are removed through the combing action. Superior quality yarn can produce in using combing making of the machine sequence in cotton count. Higher the number, finer the yarn will be. Combat yarn have high count number with best quality in using fabric making. Combat cotton yarn manufacturing process: fiber, blow room, lap, carding, carded sliver, pre-comb, grown frame, sliver, lap former, lap, comber, comb sliver, post-comb, grown frame, grown sliver, simplex, roving, ring frame, yarn, winding, reeling, bundling, baling. For high quality fabric making, combat yarn are frequently used as to make luxurious garments. Comfort as well as handling apparel is much higher in the case of garments made of combat. What is continuous filament yarn? Filament yarn, which is expression of natural silk. Continuous filament are man-made. They can be sourced from natural polymers such as paper, pulp to reduce viscose rayon etc. From synthetic polymers such as polyester, polypropylene, polyamide etc. Continuous filament are made from straight filament which are smooth and slippery to the touch. They lack the bulk, comfort and tactile hand of yarns spun from staple fibers. Produced from continuous filament yarns try to simulate the effect obtained by staple fiber yarns. First, they modified the luster of the filament from bright to semi-bright to dull. Second, they modified the structure of the filament by adding bulk and stress by various texturing processes. Those processes are primarily to increase bulk of comfort, resilience and hand or to provide stress to the yarn. The subject of texturing and the different technology used with the resulted yarn structure obtained by discussed by Lemieux and Behery. What is continuous filament yarn used for? What are examples of filament fiber? Monofilament yarn. What is monofilament yarn? Types of yarn packaging. 12 names for your yarn balls: hank, folded hank, twisted hank, sekin, pull sekin, bullet sekin, ball, cake, punnet ball, hardcore ball, cone, handshaken. What is swing thread? Swing thread is a yarn used to combine two or more fabric priced together in garments, accessories and the other textile product. Thread may be obtained of the same construction of the fiber content as a garment, but it is often different. Thread. Thread is made from a wide variety of materials. Material: cotton. Description: purpose: cotton, spun traditional thread. Purpose: general. Cotton polyester, a cotton thread with a polyester core which is slightly stained but remain the traditional look of cotton. State cotton. Fusible: linen, metallica, nylon, polyester, rayon, silk, thread, woolen. How many types of swing threads are there? Difference between yarn and thread. Yarn are used to make fabric sheet. Thread are used to joining ply of fabric during making garments. Yarn are less strong than thread. Thread are stronger than yarn. Generally, the yarn is heavy in weight in nature. Generally, the thread is lighter and weight than yarn. Yarns are used for weaving fabrics, knitting fabrics, and making thread. Thread are used for stitching products. Yarn is thinner than thread. Thread is thinner than yarn. Yarn are solid in bigger package. Generally, thread are solid in a small package. Thread numbering system. We will discuss this in another class. Different types of yarn fault. Yarn plays an important role in textile spinning. Defect-free yarns make the successive process very smooth and easy. If there are defects in yarn, it cannot be defined before weaving or knitting or yarn dyeing process. Then it will be very costly damage of the manufacturer. As its importance, yarn should be cracked or inspected not only using spinning but also in weaving, knitting, yarn dyeing process. There are different types of yarn faults in arise in textile industry. This article is represents some common defects of yarn with their explanation. Types of yarn fault and package defects in spinning. Common yarn faults and packaging defects are listed in below. Sloughs, cracks, spinner double, bad pricing and double getting, slog of bottoms, naps, shawls, soft yarn, thick and thin place, hair yarn, excessive hard yarn, rust, stain, oil slab, low strength of yarn, loose yarn, oil satin yarn, bed pricing, spun in fly, coarse screw yarn, knots, knit yarns, forgain matters. Yarn test method. Yarn test method are used when values such as tenacity, elongation or shrinkage are determined. Test room condition, linear density, breaking force and elongation at break, tenacity, force at specified elongation, hot air shrinkage force, hot water shrinkage. Test room condition, linear density, breaking force and elongation at break. Yarn finishing. Yarn finishing is a very important task for spinners because buyers are not interested to buy unfinished fault yarn after getting yarn from the ring frame has many faults like slaps, snaps, knots, hair, etc. Reducing, we talked before. The yarn gets with cop package from sizing of yarn. Sizing is an intermediate property process which is done to prepare the yarn from to weaving process. The process of applying a protective, adhesive, synthetic or natural coating upon the yarn surface is called sizing. What is object of sizing? The main object of sizing process are given below: to improve the following ability of warp yarn, to improve the fiber to fiber adhesive force in the yarn, to prevent slippage of the fiber in the yarn during weaving. Fabric manufacturing. Fabric. A cloth made by weaving, knitting or felting fibers, woolen fibers, the texture of the woven, knitted or felted material, cloth of soft plain fabric, framework structure, the fiber of society, a building, edifice. Clothing is a huge fascinating subject. There are different basic type of clothing materials, everything from linear line to polyester, but it does not. Here a coat and jumper can look and feeling completely different even if they are both made out of wool. There are many different types of fabric to choose from. Production of fabric. Fabric construction involves the fabric construction involves the conversion of yarn and sometimes fiber into fabric, having characteristics determined by the material and method employed. Most fabric are presently produced by some method of interlacing such as weaving or knitting. Weaving. Currently the major method of fabric production includes the basic wave, plain or teddy, twill, satin. The fancy waves include pile, jacquard, bobby and gauze. Knitting fabrics are rapidly increase in importance and include wave types and warp types. Russell and tricot. Other interlaced fabric include net, lace and braid. Non-woven fabric are gaining importance and include material produced by felting and bonding. Laminating process are also increasing in importance, and fairly recent development industry includes needle weaving and the swing knitting process. Classification of fabric. Fabric is made of type of fiber, content and type of construction. The method of construction will be one of 4 different types. Woven fabric are made by weaving threads of fiber together on a right angle. Knit are loops that loops on top of each other. Knit fabric having a little bit of stretch to them, and woven fabric are stiffer and steadier. Non-woven are fabric like felt, vinyl and interfacing. They can be fibers that are meshed or melt together. Hides from all sorts of animal. Fiber can be natural or man-made. How many types of machine used in knitting fabric? Weft knitting machine. In weft knitting machine, circular knitting machine, single jersey, circular knitting machine, plain single jersey, 2-track, 4-track, Tyrian fleece, jacquards, double jersey, circular knitting machine, rib, interlock, pickwick, straight bar knitting machine, single needle straight bar knitting machine, double needle straight bar knitting machine, flat bar knitting machine, flat bed or V bed, single bed, unidirectional bed, warp knitting machine, Russell knitting machine, tricot knitting machine. Knitting fault in fabric. Weft fabric fault, cause and remedies. Hallmark. Cause. Hole are the result of yarn breakage of yarn crack. During loop formation, the yarn breaks in the region of the needle hook. If the yarn count is not correct on regarding a structure, gauge, chords and density, belly knot or slipping, yarn feeder badly set. Remedies. Yarn strength must be sufficient to stand the stretch as well as uniform. Use proper count of yarn, correctly set of the yarn feeder. Knot should be given properly. Needle mark. Cause. When a needle breaks down, then needle mark comes along with the fabric. If the needle or needle hook is slightly bends, then needle mark comes on the fabric. Remedies. Needle should be straight as well as from break latch. Bent needle should be changed. Star mark. Cause. Yarn tension variation during production, bulking of the needle latch, low GSM fabric production. Remedies. Maintain same yarn tension during production. Use good condition needles. Drop stitch. Cause. Defective needles. If yarn is not properly fed during loop formation, not properly laid on the needle hook, take down mechanism to loose, insufficient yarn tension, badly set yarn feeder. Remedies. Needle should be straight and well, proper feeding of yarn during loop formation, correct take up of the fabric and correct fabric tension. Yarn tension should be perfect. Oil setting, cause when oil leak through the needle, trick when it pass on the fabric and make a line. Remedies, ensure that oil does not pass on the fabric, well maintenance as well as proper oiling. Pinhole, cause due to the breakdown or bend of the latch, pinhole may come in the fabric. Remedies, change the needle. Fly dust, in the knitting section too much line in flying and to and for that are created from yarn due to low twist as well as yarn friction. This thinning may adhere or attach to the fabric surface tightly during knit fabric production. Remedies, blowing air from cleaning and different parts after a certain period of time, by cleaning the floor continuously, by using ducting system for cleaning too much line in the floor all over, ensure that line does not attach to the fabric. Yarn contamination, cause if yarn contains foreign fiber then it remains in the fabric even after finishing. If lot count mix occurs. Remedies, by avoiding lot count mixing. Faultless spinning. Pattern, cause yarn count variation, yarn tension variation. Remedies, proper yarn count and tension should be maintained. Remarks, for dark color and plain single jersey pattern very sensitive, but in case of derivatives of single jersey rib interlock light pattern considerable. Lycra out and tension variation of lycra, cause break of lycra yarn and uneven tension of lycra. Remedies to maintain uniform tension. Yarn myths, cause yarn breakage due to the tension due to any reason and not pass through the yarn guide. It may be occur for tension variation. Remedies, yarn guide and tension must be used. Lycra and cotton mixed, cause lycra yarn twist with cotton yarn. Remedies, coordinate the yarn path, clear the guide. Weaving fabric defects with picture. In the textile industry, woven fabric is produced by interlacing warp and weft yarn. Faulty woven fabric hamper the total quality of garments such as shirt, pant, trouser, jacket, etc. As a textile engineer, you should know about the major woven fabric fault produced during woven fabric manufacturing. As its importance, this article has been those woven fabric fault with their image. Major defects found in woven fabric. Variation types faults found in woven fabric have mentioned below. Bad sleevage, broken ends of or warp, brokerage peaks or weft, loose warp, loose weft or surled, double end, tight end, the float of warp, wrong end color, miss peak, double peak, weft bar, ball, hole, oil, spot, tail out, temple mark, reed mark, slab, a thick and thin place. Bad or defective sleevage. Bad sleevage in woven fabric due to fault weaving. Here the warps being set too far apart of the things, the yarn or the finishing fabric. Broken ends warp. A defect in the woven fabric caused by warp yarn that was broken during weaving or finishing. Broken piece of weft, a filling yarn that broke in the weaving in the fabric. Broken piece. Loose warp. This type of fault is produced in the woven fabric when the tension of warp yarn is slow. Loose weft of sarnal. It is produced in woven fabric due to looseness of filling yarn. Double ends. This kind of fault is produced in woven fabric when the two ends of warp sticks get together after sizing. Tight ends. If the tension of warp yarn is more than the other ends present in the loom, then the type of fault produced in woven fabric. Float of warp. If some pulls of fabric together with the cloth roller intentionally or unintentionally, then the kind of defect is produced in the woven fabric. Wrong end color. If the produced in the woven fabric due to the wrong drawing of color yarn. Mispick. This kind of defect is produced in the woven fabric when the operator starts a stop machine without picking the broken weft from the shed. Mispick. Double pick. It is produced in the woven fabric when the cutter doesn't work properly. Weft bar. When the count of yarn varies from the cone to another cone, then the bar of weft will appear in the fabric after weaving. Ball. If the warp is too hairy, then the reed will create a ball in warp yarn in between the reed and heel shaft. If the ball is small enough to pass through the bend of reed, then those will form the ball in fabric. Hole. The fabric imperfection in which one or several yarns are sufficiently damaged to create an opening, oil, spot or satin. Tail outs. If this kind of hole is produced in woven fabric if the cutter doesn't work properly. Temple mark. If the placement of the ring in the temple bar is wrong or pressure of the template of the fabric is too high, then this type of fault produced. Reed mark. Slaps. Thick and thin place. Fabric testing machine. Wet processing engineering. Wet processing engineering is one of the major streams in textile engineering, which refers to engineering of textile chemicals, process and associated applied science. The other three streams in textile engineering are yarn engineering, fabric engineering and apparel engineering. The process of stream are involved or carried out in an aqueous of stage, hence it is called a wet processing, which usually covers pre-treatment, dyeing, printing and finishing. The wet processing is usually done in the manufactured, assemble and interlacing fibers, filament and yarns having a substantial surface area in relation to its thickness and adequate mechanical strength to give it a cohesive structure. In other words, the wet processing is done on manufactured fiber yarn and fabric. All of those steps are required. Aqueous medium which is treated by water. A massive amount of water is required in those processes per day. It is estimated that on an average almost 50 to 100 liters of water is used to process only 1 kilogram of textile goods. Depending on the process, engineering and applications, water can be of various qualities and aptitudes. Not all water can be used in textile process. It must have some certain properties, quality, color and attributes of being used. This is the reason why water is a prime concern in wet processing engineering. Water consumption and discharge of water are the two major concerns. The textile industry uses a large amount of water in the varied process, especially in wet operations such as pre-treatment, dyeing and printing. Water is required as a solvent of various dye and chemical, and it is used washing or rinsing bath in different steps. Water consumption depends upon the application method, process, dye stuff, equipment, machines and technology, which may vary mill to mill. Material consumption, longer process sequence, processing of extra dark color and reprocessing led to extra water consumption, and process optimized and right first time production may save water. Pre-treatment process, sizing, desizing, scouring, bleaching, mercerizing, dyeing, printing and finishing. Dyeing is the application of dyes or pigments on textile materials such as fiber, yarn and fabric with the goal of achieving color with desired color fastness. Dyeing is normally done in a special solution containing dyes and particular chemicals material. Dye molecules are fixed to the fiber by absorption, diffusion or bonding with temperature and time being key control factor. The bond between dye molecules and fiber may be strong or weak depending on the dye used. Dyeing and printing are different applications. In printing, color is applied to a localized area with desired parameters. In dyeing, it is applied on the entire textile. Dyeing types: solution dyeing, fiber dyeing, yarn dyeing, fabric dyeing, union dyeing, cross dyeing, product dyeing. Dye types: acid dyes, direct or substantive dyeing, moderate dyes, wet dyes, reactive dyes, dispersed dyes, azoic dyes, sulfur dyes. Printing. Textile printing referred as localized dyes. It is the application of color in the form of paste or link to the surface of a fabric. In a predetermined pattern, printing designed onto already dyed fabric is also possible. In properly printed fabric, the color is bonded with the fiber so to resist washing and friction. Textile printing is related to dyeing, are applied to the certain parts only and in sharply defined patterns. In printing, wooden blocks, stencils, engraved trinket to prevent the color from spreading by capillary attraction beyond the limits of the pattern or design. Finishing. Textile finishing is the term used to a series of processes to which all bleached, dyed, printed and certain grey fabric are subjected before they put on the market. The object of textile finishing is to render textile goods fits or their purpose or end use another or improve serviceability of the fabric. Finishing on the fabric is carried out for both aesthetic and functional purpose of improve the quality and look of the fabric. Fabric may receive considerable added value by applying on or more finishing process. Finishing process include rising, calendering, crease resistance, filling, softening, stiffening, water repellency, moth proofing, mildew proofing, flame retardant, anti-stain, oil resistant. Garments manufacturing. What is garments manufacturing? Garments manufacturing industry is a sector that manufactures semi-durable consumer goods to fulfill the basic clothing needs of individual. Garments manufacturing industry produce all kind of clothes and accessories. What goes on the garments manufacturing industry? Apparel manufacturing process involves produce design, fabric selection and inspection, pattern making, guarding, marking, spreading, cutting, bundling, sewing, pressing or folding. Garment production consists of multiple steps. Leading fast fashion brands have the resource to produce hundreds and thousands of items of clothing within a few weeks. Once design have been approved for a smaller brand, producing garments takes a little bit longer. What are the steps of garments production? Here's a step-by-step guide to garments production. Pre-production. Pre-production consists of fabric and trims sourcing, fabric development, pattern making and sampling. Fabric and trim sourcing, pattern making, production planning, cutting process, manufacturing and quality control, delivery. Here's a step-by-step guide to garment production. Pre-production. Pre-production consists of fabric and trim sourcing, fabric development, pattern making and sampling. Fabric and trim sourcing. After the design have been finalized, the garments manufacturer will help source the fabric, need to bring them to life. Experienced garments manufacturers have a list of trusted textile manufacturers that can sell a variety of materials. Pattern making. Pattern makers have a technical expertise to break down the design into 2D pieces. They use advanced software to break out the components of garments. Sampling. Sampling are the prototype of a creation. They are sewn individually and used to test the garment in case any pattern adjustment are necessary. Production planning. The production planner in the garments factory will schedule all activities in advance. The planning team will ensure that all activities are completed on time. As the batch is being produced, the team will fill out the details on a time and action calendar. Cutting process. Fabric is by far the most expensive item when it comes to garments manufacturing. Garments manufacturers have a responsibility to make sure that the purchased fabric is being utilized fully. The pattern makers and the cutters on the floor have ensured that the minimum wastage when cutting fabric. Modern garments manufacturers like Lefty Production Co. use laser cutting for gather efficiency and to prevent wastage. Manufacturing and quality control. The amount of time need to manufacture the item on your line will depend on the complexity of the design. The more complicated the design, the longer it will take to manufacture. The garment manufacturer will carry out quality checks during the manufacturing process and report to the fashion house. Quality checks are needed to catch and fix error in a timely manner. Once production is completed, our company will be given into a review on the pieces and check for quality. You have the right to reject items and send them back to the factory if they don't meet your standards and demand replacements. Delivery. After the item have been reviewed by the fashion company, the rest of the order will be delivered to your warehouse. A step of garment export order execution. A step of garment order execution. A step of garments order execution are described as follow. Inquiry of a product. First of all, supplier collect the product from the buyer and inquire the product. Lead time, space availability. Lead time is the time difference between buyer order confirmation date and delivery date. Within time, garments must be delivered. Costing. Costing means the way of calculating the cost of production of garments. Costing is done considering fabric price, accessory price and cost of making. Order confirmation. An order confirmation is a written confirmation which is issued by a buyer to the manufacturer. It serves as tool to avoid confusion and mistake in case order does not conform to the original offer. Purchase order (PO). A buyer generated document that authorized a purchase transaction. It includes description of product, qualities, price, discounts, payment terms, date of shipment, etc. Guidance of payment. Telegraphic transfer (TT). It is the cash payment. Now it is not used. LC master provided by buyer. LC or letter of credit is a document which prepared by buyer to the manufacturer. T&A calendar making. T&A or time and action calendar is made by manufacturer to complete the production within a specific period of time. Fabric and accessories booking. After making a T&A calendar, fabric and accessories booking is necessary. Without fabric, all materials used in garments are called accessories or trimmings. Back-to-back LC. Back-to-back LC is issued on the strength of master LC. It is issued by the exporters bank to the suppliers to produce raw materials. It has 70 to 80% financial value of master LC. Sampling. The process of collecting or making sample is called sampling. Type of garment sampling. Photo sampling. Features. Those samples are made by manufacturer by available fabric and accessories. Those samples are made before or after order confirmation. Purpose: by those sample, buyer check whether or not the factory can make the garments. Fit sample. Features: those samples are made by manufacturer by available fabric and accessories. Those samples are made after order confirmation. Purpose: by those samples, buyer checks the fitness or measurement of the fabric, measurement of the garments. Pre-production sample. Features: those samples are made by the manufacturer by actual fabric and accessories. The samples are made after order confirmation. Purpose: buyer will not bulk production following PP sample. Buyer will do bulk production following PP sample. Size set sample. Features: those samples are made in all size. Those samples are sent to the buyer. Those samples are made in production floor. Purpose: those samples are made only PP meeting or internal purpose. Production sample. Features: those samples are collected from the production floor while bulk production is running. Those are sent to the buyer. Purpose: by those samples, buyer compare production sample within the PP sample. Garments test sample. Features: those samples are collected from the production floor while bulk production is running. Those are sent to the testing house. Purpose: by those samples, testing house test different aspects of the garments and send test report to the buyer and factories. Shipment sample. Features: those samples are not mandatory. Those are sent to the buyers after the shipment of the product. Purpose: by the sample, buyer compare the production sample with the shipment sample. Fabric and accessories in-house. Here confirms all fabric and accessories in their hand. Inspection of the inventory and report making. Checking the quality and quantity of fabrics and accessories in-house. After checking, a report is made after the test data. Pre-production meeting. Pre-production meeting. This meeting is held before going to bulk production. This meeting is considered by following person: buying house quality control, factory quality control, buying house merchandiser, factory merchandiser, cutting master, pattern master, production manager, sample man. Pattern and marker making for bulk production. Pattern is a hard paper which is made by following each individual component of a style of garments. Marker is a thin paper which contains all components of different size of particular style of garments. Trial or pilot cutting. Little amount 200 to 300 pieces of garments of fabric are cut for checking the efficient and production cost of the garments. Bulk cutting. Here total fabric required for bulk production are cut. Numbering, bundling, sorting. After cutting of fabric, numbering, bundling and sorting process are done. Then cut pieces are sent to the sewing section. Production line setup. Production line setup is the arrangement of sewing machines where the input of the first machine is cutting part of the fabric and the output of the last machine is complete garments. Sewing. Cutting pieces are attached by sewing to make the complete garments. Different types of sewing machines are used in production line. Finishing. Finishing includes ironing, packaging, cartooning, etc. Pre-final inspection. This type of inspection is done only by factory QC. It may be at the end of the production line. Final inspection. Final inspection is conducted by the buyer QC, tender QC, self-inspection conducting by the factory QC. third-party inspection conducted by the testing house. Delivery. If everything is okay, then supplier send the goods to the buyer. I will discuss details in next class. I hope you will like. Give comments for this video. Thank you for watching.